Hey there, welcome to this video on finding the average rate of change of a rational function. What we're going to do today is look at graphs of rational functions, tables of values, as well as rational functions in symbolic or algebraic form, and we're going to calculate the average rate of change. Right behind me over here is the average rate of change formula. It's the change in y values over the change in x values, also known as slope, y2 minus y1 over x2 minus x1. Let's go ahead and look at kind of our definition. The average rate of change is the average change between y values for each unit of x over a specific continuous interval of a function. That's important, especially with rational functions, is that the interval has to be continuous. The average rate of change for an interval corresponds to the slope of the line through 2 points that end at the interval. So here you can go ahead and see an example. Here are 2 points, and we're calculating the average rate of change, right? The rise over the run. Now, how do we find the average rate of change over the continuous interval x1, x2? Well, you have to go ahead and first find the corresponding function values. You have to evaluate your function at x1 and at x2. Once you have your 2 points, you can go ahead and do step 2, which is calculate the average rate of change over the interval. So I plug in my delta f of x over my delta x, which is f of x2 minus f of x1 over x2 minus 1. If you want, you can go ahead and rewrite it this way, y2 minus y1 over x2 minus x1. Very, very plain and simple. And you've done it lots of times. So here is our first example, and we're asked to find the average rate of change for the function over the specified interval. Give exact values or values rounded to 3 decimal places. So that's very, very important, okay? Now we want the average rate of change over the specified interval, which is 5 to 7. Okay, so step 1, I need to go ahead and find out, okay, what are my function values? So I'm going to do f of 7 first. So f of 7. And all I'm going to do is just plug this in. We have 3 times 7 over 7 squared minus 3 times 7. So we get 21 over 49 minus 21, which is 21 over 28, which it looks like this reduces to 3/4. Next, I need to know what is f of 5. So I'm going to go ahead and I'm going to plug in 5. So 3 times 5 over 5 squared minus 3 times 5. So this is 15. I almost wrote 25. 15 over 25 minus 15, which is 15 over 10, which reduces to 3/2. Okay, so what I'm going to go ahead and do next, step 2, is I'm now going to head and plug these values into our formula. So again, we want our delta f of x, the change in our y values over the change in our x values. So what is f of x2 minus f of x1 over x2 minus x1? So it looks like we have 3/4, which is 0.75, minus 3.2, which is 1.5, over 7 minus 5. So it looks like negative 0.75 over 2. So I'm going to go ahead and use a calculator, and notice they say round it to 3 decimal places. So negative 0.75 divided by 2. And we get negative 0.375. So we can say the average rate of change from 5 to 7 inclusive is negative 0.375. And that's exact. So I don't have to say it's about that, it is that. And that is 3 decimal places. Very important. Let's go ahead and check out the next example. Now they say find the average rate of change for the function over the specified interval. Again, the specified interval is given, but this time it is in inequality notation from -6 to -3. No problem. Give the exact values or values rounded to 3 decimal places. Okay, so in the last example we did exact, that was exactly that. This one, who knows? Maybe we'll have to go ahead and round. So step 1, again, I need my function values. I need to first plug in, okay, what is f of -3? I'm going to plug in the second one because that value goes first. And it looks like we have 4 times -3 minus 1 over 2 times -3 squared plus 3 times -3 minus 2. Okay, so we got some calculating to do here. Looks like this is -12 minus 1 would be -13. Over here we have 9 times 2, that's 18, minus 9 minus 2. So 18 minus 11 gives us 7. So we have -13 over 7. Now that's not a nice number. Can't do some mental math there. So what I'm going to do is I'm going to go to my calculator. Now I recommend for you guys, if you need a calculator, go to desmos.com, and underneath their math tools here, you can get a scientific calculator. And here's their scientific calculator. I'm just going to plug in, okay, what is 13 divided by 7? And over here is your answer. So approximately 1.857, 1.857, negative 1.857. So I'm using 3 decimal places because they said 3 decimal places. All right. All right, now I need to go ahead and get my other function value, f of -6. So now I'm going to plug in -6. We have 4 times -6 minus 1 over 2 times -6 squared plus 3 times -6 minus 2. And again, we need to go ahead and simplify. Looks like this is -24 minus 1, -25. Over -6 squared, that's 36. Times 2 would be 72. Okay, minus 18 minus 2. So that's subtracting 20. So it looks like we have 52. Okay, so -25 over 52. Again, I'm going to go back. Let me clear all this. 25 divided by 52. And it looks like it is approximately 0.481, right? If I'm going to round to this place, I need to look here. 5 or more up the score, 4 or less, let it rest. So 0.481. Okay, so those are my values. Now I need to go ahead and plug it into my average rate of change. Okay, oh, and before I do that, I want to go ahead and not forget my negative here. It's a negative. Okay, so step 2. I'm going to go ahead and plug it into delta f of x, the change in the y values or the function values divided by the change in our x values. So I can go ahead and plug in y2, which it looks like is negative 1.857 minus negative 0.481 all over the change in our x values. So -3 minus -6. Okay, so we can go ahead and utilize our calculator. Okay, so our numerator is negative 1.857, and I'm adding 0.481. Okay, and here's our answer, negative 1.376. Okay, so again right here, right, 2 negatives make a positive. So I'm going to add that to that negative value. And then in our denominator, -3, take away a -6. Again, we're going to add -3 plus 6 is going to be a +3. So I'm going to take my value, which is here, -1.376, and we divide by 3. Oh, wait. No, not that. There we go. I'm going to hit return. And I want -1.376, and we're dividing by 3. Okay, and so here's our answer, -0.459. Okay, so there is your answer. All right. Okay, here is a practice problem. Please pause the video, and I would like you to try this now. All right, hopefully you went ahead and tried this. Step 1, did you get your function values? Okay, so we get our function values, and if I plug in -1, we get -2 over 20, which is -0.1. Next, if I plug in 2, f of 2, well, that gives me 4 over 2, which is 2. So those are our function values. Step 2, you need to plug those values in. So 2 minus -0.1, you add them, and we get 2.1, and then in our denominator, we get 2 minus a -1. Again, you add 2 negatives, make a positive. So 2 plus 1 is 3. We divide, and we get 0.7. So the average rate of change over that interval is about 0.7. Here is another practice problem. Please pause the video and go ahead and try this one. Okay, hopefully you pause the video, and here is the solution. So this time you're going to have to round. Did you round to 3 decimal places? Check. Did your f of 4 value yield you a -0.085? And then did your f of 9 value give you a -0.037? Okay, so those are your function values. If we plug those into our average rate of change formula, along with the change in x values, you get approximately 0.024. So there is your average rate of change. Okay, next. The next couple of examples are going to focus on finding the average rate of change from a table of values or from a graph of a rational function. Now, this is very, very easy because we're still finding the function, the average rate of change of the function over a specified interval. So they're giving us an interval here, 0 to 2. But this time, when we do step 1, very, very simple. I can go ahead and say, okay, what is f of 0? Well, 0 for my x values are located here. So it is approximately -0.333. Okay, then what is f of 2? Well, let me change colors here just to make sure this is really obvious. F of 2, well, my x value 2 is right here. So what's the output? -0.6. Okay, so now step 2, if I'm calculating average rate of change, delta f of x over delta x is going to be equal to my f of 2 value minus f of 0 over 2 minus 0. So a lot of that first computational part is gone. That makes this part really, really straightforward and simple. So if I plug this in, we get -0.6 minus a -0.333 all over 2 minus 0. That's going to give us a 2. So again, 2 negatives make a positive. We can go ahead and add this, and we get, looks like, well, let me go to my calculator. So clear. We have -0.6, okay, and I'm adding 0.333. So we get -0.267, and we want to go ahead and divide that value by 2. So we get negative 0.134 if we're going to the nearest through third decimal place. Let me just bring that up. Okay, so here is your average rate of change, right? I simplified the numerator, divided by the 2 in the denominator, and we get this. So we can say the average rate of change over 0 to 2 is about negative 0.134. Straightforward. Okay. Here is a practice problem. Please go ahead and pause the video and give this one a go. All right, hopefully you pause the video. Again, first thing, find your function values. So if you find the function values, f of negative 8 is negative 1.4. F of negative 7 is negative 1.5. And then we can plug those into our average rate of change formula. And you should get the average rate of change to be about negative 0.1. Okay, last example that I'm going to go ahead and give you here, this time it is from a graph. So when they say find the average rate of change for the function over the specified interval, which is negative 7 to negative 4.75, I'm looking for those function values. So negative 7, well, negative 7 is right here. So here's my output. And then to negative 4.75, which is here. So look, those are my values right away. Step 1, I'm going to find my function values. F of negative 7 is negative 0.25. F of negative 4.75 is equal to 0.714. So there's my function values. Next, I can go ahead and just calculate delta f of x or your delta y's. Okay, so my numerator, we have 0.714 minus negative 0.25. Okay, over negative 4.75 minus negative 7. Okay, and don't drop those negatives. Be careful. Those negatives will wreck a lot of people. Okay, so we're going to go ahead and calculate this. So it looks like 2 negatives become positive. So we have 0.964, right, over 2 negatives, again, make a positive, and that looks like it will be 2.25. Okay, and then we need a calculator to go ahead and divide this for us. I have a feeling this is not going to be exact, so we'll put the approximate signs. Okay, so it was 0.964 divided by 2.25. Okay, and we get 0.428. So say the average rate of change over negative 7 to negative 4.75 is about 0.428. Okay, here is the last practice problem. Please pause the video. Go ahead and try this one. All right, hopefully you pause the video. Here is the solutions. You got to find your function values first. from the graph, and then you go ahead and plug them in and evaluate. All right, that will do it for this video on finding the average rate of change of rational functions. Again, we looked at finding the average rate of change from symbolic form or algebraic form. We looked at how to find them from a table of values and how to find them from a graph. Okay, so hope you enjoyed the video. I'll catch you next time. Be safe, be easy. Peace.